Welcome. In this lesson, we are going to review how to solve a simple static suspension question. So let's look at my example here. So once again, first thing we're going to do is break everything down into their x and y components. We have two force vectors here, the tension of rope 1 and the tension of rope 2. So I'm going to break them down into their x and y components. So I have an x that goes this way. So this is T1x, and I have a y that goes up this way. This is Ty1. Okay? Now, I over here have an x that goes this way. This is T2x, and I have a y that goes this way. Okay, going up. That's going to be T2y. Now, looking at this, one thing we know is this weight is not moving. It's suspended. So if it's suspended, if we remember, that means everything must be in equilibrium, meaning everything is balanced. So we're going to first look at my x's, because my x's here have to be balanced. This x must equal to this x, because these are the only forces pulling in the x. I also have a y force pulling down this way, which is my f of g. Okay? Now this f of g in the y must equal to the combination of these two y forces. Alright, so let's start off here. I'm going to first find my tension of x. Why do I want to do that? Because in the x, if I'm looking at my x components, I know here that my sum of my x, of my f of x, must be equal to 0. So I only have two x's here. So that means I know that T1x, the tension of rope 1 in the x, plus the tension of rope 2 in the x, must be equal to 0. I know this tension here is negative. So this is technically a negative. So if I move that over there, I know that tension 2 in the x must be equal to tension 1 in the x. Okay? So, how do I find tension 2 in the x? Well, if this angle is 60, that means this angle here must be 60. All right? Now, if we remember Sir Coxeter-Tix, sine is y over resultant, cosine is x over resultant, and tan is y over x. We could look at which one we want to do here. So I know my resultant is 250 newtons. I could use this to find this x. So in this case here, I'm going to use cosine. So I know, because we're trying to find x and we know the resultant. So I know cosine, so we're using Coxeter. So cosine 60 is equal to my x, so that's t of x, divided by my resultant, which is going to be 250. Okay? So in other words, we rearrange this, I'm going to get 250 cosine of 60 is equal to Tx. I work that out. I'm going to get 125 newtons is equal to my x value of my tension. So if this is 125 newtons, that means this here is also equal to 125 newtons. Okay? So we are done all of my x's. The reason why I want to do my x is so that now I could find my y's on this side, and I could find my y on this side. This side we already knew we could find my y, but now I could find my y for my vector on that side, for that tension. So now I'm going to look at my y components. Alright, so if I'm looking at this here, this is 50, right? So once again, for my y components, we want to figure out both of these y's, and then we're going to add them up. So I'm going to have here, we're going to have to use sine for the y. So I'm going to say sine. Oh, in this case, actually, we're going to use tangent because I know my x and I know my y. So I'm going to have to use Tix. For Sir Coxeter-Tix, I'm going to use Tix. So I know tan 50 is equal to, we're going to have Ty, my tension, my y, divided by my tension in my x. So in this case, it is equal to my tension in my y divided by 125. with newtons, which is my tangent, my x. So in other words, I have 125 tangent 50 is equal to my tangent and my y. I plug that in, I'm going to end up getting my tangent and my y is equal to, and this is y2 by the way, is equal to 149 newtons. Okay? So, now I have to look at my other y component, this one here. For this one, I know the resultant, and I want to find y, so I'm going to use SIR, so sine. So we know here I'm going to have, we have 250 sine 60 is going to be equal to my ty1, okay, my tension in y1. When I plug that in, I'm going to end up getting a total of 217 newtons. Now, let's look at this here. I'm just going to move this over this way. Now that I know these, I can actually find my mass of my object. Because on our free body diagram, these y's must equal to the weight pulling down. So that means I have to add these y's together to figure out what is the weight of my mass. So in other words here, we know that the sum of my force and my y must equal to 0. I have it down here. So in other words, we know that T1 in the y plus T2 in the y minus my force of gravity must equal to 0. So in other words, we have T1 y plus T2 y must equal to the force of gravity, which is my weight. So now I could find my force of gravity, which is my weight, or W, we could put W for weight. That is going to be, we have 217 newtons plus 149 newtons. And that's going to end up giving me a total of 366 newtons. Okay? But I want to know my mass. So I know force of gravity is equal to mass times gravity. Okay? All right. Now to solve for mass, I just divide both sides by gravity, divide both sides by gravity. So I end up getting mass is equal to my force of gravity divided by gravity. Well, my force of gravity, or my weight of the object, is equal to 366 newtons. And I want to divide it by my gravity, which is 9.81 meters per second squared. That's going to end up giving me a total of 37.2 kilograms. Okay, so that is going to be my mass being used there.